Okay, so we're back at the surface table. So basically this will be the main arbor. There's the slidey bit, as I've often referred to it, so that's the bit that's going to do the sort of sliding work up and down on the arbor. So there's the cartridge we've just made, which will fit, hopefully, he says, into there. So that's a good fit in there. And then there's the die that's the biggest of all the ones that we've measured at this size, which should, he says, yeah, that's a good fit. I'm not going to press that in too hard. I think what's happened there is, as I've deburred the front edge, it's probably thrown a secondary burr up. I'm not going to mess around too much with that. I'll do that at the bench in the vise, but you get the idea. I'll clean that secondary burr off that corner. That's all that's stopping that. So now when this is held in the tailstock, obviously I've got to captivate with the stud. Once I've drilled my hole through here, that'll make this unit captive on the arbor, and then I've also got to drill my hole in here where this piece will go through, and this grub screw will then thread in onto the slot that I need to mill in the cartridge, and clamp the cartridge in place. And then I've also obviously got to drill my 3 holes in the cartridge itself to clamp the die. But you get the idea now. That'll push up to the job, and then you'll engage the thread, and this will basically move down to thread, and this design as it's set will give 60mm of travel on, based on the length of this slot. You could go further than that by increasing the tailstock in a bit more and having a second go, but at some point, whatever bar you're threading is going to run into the front of this arbor. So I don't know what the maximum thread length is. It'll probably be somewhere about 100mm or something like that, but to be honest, for using a die, it's very, very rare that you would be using one that far down. So that's the general idea. That's the design together for the first time. So the next job now is some milling and drilling work. So 2 holes to put in this bit, 3 holes to put in this bit, and a slot to mill in it. So we'll bring you back at the mill when we're doing the final bits of milling and assembly. Okay guys, what we're going to do now is put the 2 holes in the slidey bit, and I know I've shown these at 90 degrees opposed to each other on the drawing. That's not really necessary. I don't know why I drew it like that really. It doesn't matter whether they're in line or 90 degrees. So to make the manufacturing easier, I'm just going to do them in line. So basically I'm going to put the hole in the front for the threaded hole, and then I'm just going to pitch backwards while I'm on centre line and drop the hole through for the retention pin. It makes no difference. So I'll move you to the mill and show you the setup that I'm going to use, and then we'll pop both those holes in. Right, so here's the setup guys. I'm going to hold the part in the vise this way. I can clamp on the parallel faces that way without risking marking or marking any other bits. So we're going to set up, find the centre, find the front face, and I know because of my dimensions that I've worked to that I'm all to drawing, so I can work straight to drawing in terms of the centre, and also to pitch across axially to find this hole and the second hole. Now when I break through the second hole, this is a through hole all the way through, what I'm going to use is I've got an old piece of power hacksaw blade, and I'm just going to slide that underneath where I'm breaking out, just to make sure I don't put any apprentice marks in the top of the vise, and that should do just fine I think. So we'll get going now and we'll find the centre. I can just get past centre with the centre finder. It's very close, but It's just enough room to get in there, so we'll find the centre now. That's us on centre now, that way, and we've pitched in 10mm for the first hole to go in. Just look at that, make sure that looks right. It does. If it looks right, it is right. So what I'll do now, I need to strip this down, put the chuck in, and I'll bring you back when I've done that. Okay, so we'll put the first hole in, which is tapping drill for M8, so 6.8mm. We'll just pop a centre drill in first. Not forgetting this is our lovely stainless steel. Yep, I need to be a bit higher up than that. Put a decent countersink in the front. That's ready for tapping now. I'll just go and get a tap. Okay. Will we power tap? Why not? Let's give it a try. I won't be able to reverse it straight back out because of the transformer, but I'll certainly be able to see if I can get it through the hole. We'll give it a go. And that's why. went in okay. There we go, that's that bit done. So we're now going to pitch across to our second hole over here for the retaining bolt, and I think that was 90mm on the drawing. Yeah, that's 90, so I'm already at 10, so I've got another 80mm to move over in the y-axis. That should be us at 90mm, I think. I'm going to have to drop the head down a little bit just for this centre drill. Yep, looks right. It should be 10mm in from this far end, which looks about right, so that's good. So put some speed back on. Countersink that now. Run that at 345. There we go. That's it for the hole drilling. I just need to turn that over now, countersink the other two on the other side just to take the burrs off, and I'll try and poke the Noga tool through to try and deburr the inside of those holes in there, and that concludes the machining on this part. So the next thing we'll do is load up the cartridge that's going to go in the front. I've got a slot to mill in it and 3 holes, and then that should be all of the machining complete. So I'll bring you back when we're doing that final piece. Okay, so we've got the cartridge now that's going to hold the die in the chuck. So we've got 2 operations to do here. We've got 3 holes to drill to hold the dies in place, and we've got a slot to mill in the back. Now I'm going to mill the slot coincident with the top hole, so I can do both of those in one setup, and then I'm going to have to move the part twice to machine the 2 angled holes. And what I've done there, we're going to use an empirical method for want of any better one. I've tried measuring angles with a protractor and things like that, and I'm just struggling to get anything sensible. So what we're going to do, I've just marked out by eye where the holes sit on the die. So I've got three lines. I've marked those on with a square, and basically when I set this up, I've used my square to set up on the line so I can see the lines vertical up against that square, and that's going to be good enough, I think. So what I've done is, there's always a front and a back to a die. The front is always the one with the writing on, and it's got more of a lead at the front, the back of the die doesn't have such a big lead on, and you can actually use these both ways round. If you need to get tight up to a shoulder, you would use the front of the die first and spin it round, use the back of the die, and you'll get slightly more threads up to the shoulder. But I've measured these, the holes are central about the dies as best I can measure them. So basically I've just eye-sighted using a vernier, you know, where the centre of the holes are, and they're about 4.5mm to the centre. So what I'm going to do is put the holes in at 4.25, so they're 10th thou shorter or behind where they should be, and hopefully what that will do is, as I advance the two screws in the outside, that should make sure the die is fully seated back to the back face so that it can't be tipped. I don't know whether that's going to work, but that's what I'm going to do. So I'm going to move the holes slightly off centre. So we're going to touch on the front face, 0, touch on each side or touch on one side, get myself on centre, and we'll put the first hole in. Then I'm going to touch on the back, wind in or go from my front dimension, wind across to the centre of my slot. Then we're going to strip the chuck out, put the collet chuck in, put an end mill in, mill the slot, and then we'll switch that back out again, put the chuck back in, and machine the remaining 2 holes. So that's what we're going to do now. So I'll bring you back when we're setting up to drill the first hole. So I'm going for M5 here. So this is a 4.2 drill. Just countersink that. Got my tapping compound ready. So after yesterday's success, we'll go for another power tap. This is a machine tap. So we go on the slowest speed, which is 95 RPM. There we go, that's the first hole done. So I'll cut the camera now and I'm going to remove the chuck, put the collet chuck in, ready for milling the slot in the back. Okay, we've got a 10mm end mill in. The slot needs to be 10mm wide, not critical, it's just clearance on the bolt, so on the grub screw with the brass tip on it. I've touched on the top, so I've pitched across to the right place per the drawing, so the centre of the cutter is 10mm in from the back edge. I've touched on the top and set a 0, and we're now going to wind down 5mm and machine a slot into there. There we go. So that's a 10mm end mill, and that's running at 960 RPM, solid carbide, and I was going at 1mm depth of cut there. That's got my slot in there now. So I'll bring you back in a moment. I'm just going to now swap this back out, the collet chuck for the quick change chuck, and then we'll reset the part twice and drill and tap the other 2 holes for the die retention. There we go, that's 2 holes done. I'll not film the third, it's the same, so I'll bring you back when we've got that piece completed. So there we go guys, that's that piece finished now. So you can see I've just slotted the die in, the M8 die, which is the first one I'm intending to try this with, and that all fits well. Got the slot in, got the 3 holes in, and you won't be able to see, but I've eye-sighted down the 2 outer holes, the ones that I've kind of eye-sighted the hole centres on, and they line up pretty well with the dimples in the die, so I'm happy with that. What I do need to get is some grub screws. I've got some on order. These are M5s. I've got no M5 grub screws at the minute. I've got some cap heads and other things, and I could use some of those in the short term, but I think the grub screws are on the way. So so that is it. That concludes all of the machining on the die holder. What remains now is to build it all up together, which I shall do in a minute, and we'll put that back in the tailstock and show you it in the tailstock, and then that really concludes the manufacture of this this tool, certainly for this die. I'm going to make another one of these holders, you know, identical to this, but for the small Jacob's chuck to go in, because I want to try the sensitive drilling idea that I've spoken about a few times. So that will be a separate video, or I might just make that, you know, and show you the end result one way or the other. So I'm pleased with that. We'll join you at the lathe in a moment when we're putting it all together. Okay, so we'll try and assemble this now. See if it all fits together. Hopefully it will. So we'll put the arbor in first, and then I'm just going to put a thin coat of oil on that. I'm going to follow that up with the slidey bit, as it's come to be known. That's a really good fit. There's no play on that at all. That's nice, and it slides nicely. We'll follow that up with, I'm using some nylock nuts, because once I've got these on and in position, they don't need to be tight. They just need to lock in the same place and not move. Well, that's a good start. It all fits. Who put that there? Cheers. I was celebrating a bit early. I really need to look at my my spanners. I don't like using adjustables, really. But that'll do for now. There's a bit of play on that. It's nice. The next thing is the cartridge that we've just made. Which is a good fit. And finally the grub screw with the brass tip. Just get an Allen key for that. Wrong one. Let's try this one. And what I'm hoping is that I can feel the flat. Yeah, I can definitely feel that. So I'm just rotating that end piece until, let me do it with the other hand and you can see what I'm doing, until I can feel it's on that flat. Bit of a nip. And there we go. So that's the design made and in the tailstock. So I'm happy with that. That all works as it should. I think for drilling, I'm just trying to get a feel for how sensitive that actually is. That is quite good actually. Obviously as I use this more, it's all going to bed in, and it'll get smoother. There's no tight spots. So that's it guys, that is the tailstock die holder. So obviously the proof of the pudding is in the eating as always. We need to trial this, and I've got a job lined up for it, which is why I've made it. So the job I've bought some 8mm square mild steel, and I'm going to be replacing all of these M8 grub screws that I've got in my tool holders, in my Dixon tool holders, with the proper as per this one. These are the old ones that came with the lathe, but I'm going to be making a load of these screws up with the square on the top. So that's going to be probably one of the next jobs I do on the lathe, and we'll be trying the die holder out on that job. So I hope you've enjoyed that. It's been a bit of a long series, I suppose. I've tried to split it up and keep the episodes reasonably watchable so they don't get too long. As I said, there's drawings that I've made. You've seen them several times throughout this series. I'm going to make those available to anybody that wants them. I'd probably suggest you wait and see if this works first. The only doubt that's in my mind, and this is a doubt, the die itself, or the dies themselves, there's no guarantee that because this is all fairly concentric, or it should be with the way I've made it with the tolerances. So I'm fairly sure that this front cartridge is pretty much on the centre line of the lathe, within a few thou. There's no guarantee that the thread that's in the die, especially with them being a split die, is bang in the centre. So there is a risk, because I've made this all so tight in terms of tolerances, and there's no play in any direction really. If the dies themselves, if the thread isn't absolutely concentric to the OD and it's not in the centre, then there's a risk that the threads will be undersized, because it will be off centre, which will cut an undersized thread. And I need to trial that, and Chris rightly pointed that out, one of my subscribers, and it's been in the back of my mind ever since he pointed it out, and I've been thinking about it. If it becomes a problem, I've been thinking about it, and there is a kind of a workaround. So when I machine another one of these for the die, if this is a problem with this eccentricity, I'm going to actually turn this cartridge in the 4-jaw chuck, and what I shall do is turn two separate diameters, so one diameter to locate in the holder itself, and the front diameter and the bore will be turned separately, and I shall do those in the 4-jaw chuck, and I shall probably offset it by, I don't know, 10 thou, something like that. So then I can turn round. Now thinking about that, I can't, because the grub screw's in there. I'll need to give that some thought. There'll be a way around it, but I was thinking of using it like an eccentric cam almost in this front part to allow it to turn the die round in the front, to get it on centre. We'll see how we go. We'll see how this works. I'm hoping it's going to be okay. Certainly for sensitive drilling, I think that's going to make a really useful sensitive drilling device. I'm pleased with all the lengths. You know, when I designed it so that at full retraction the unit butts up against the back of the taper, and at full extent it's still, there is a bit more play in at full extent obviously, because there's not as much location in here, but there's still enough to hold it you know, true-ish. And by the time, if you're threading, by the time you're that deep, or even if you're drilling, obviously the front end's going to be supported in the workpiece anyway, so I think the design's good. We're just to see whether this eccentricity thing becomes a problem. So I hope that's been enjoyable. I've certainly enjoyed designing it and making it. It's been an interesting project. As I say, I'll make the drawings available to anybody that wants them. Just drop me an email and let me know, and I'll send the amended versions. I've got a couple of amendments to make to them, but I'll send those out to whoever wants them. And if anybody's wanting to have a crack at this and they're struggling with it or whatever, just drop me an email and I'll try and help you along with it. So as I said, I hope you've enjoyed that. Thanks for watching. As usual, thanks for subscribing. If you've not already subscribed, please do so, because it will help the channel. Please comment. I enjoy the comments, good or bad. Well, let's not call them bad, let's call them good or room for improvement. So, you know, feel free to drop me a comment. It helps me tailor the material to try and suit everybody's taste as best I can. And we'll catch you very shortly on another video when we'll be doing something else, and I'm not sure what that's going to be yet, but we'll catch you on a video very soon.